Hi all, my name is Rifan and today we are discussing about with processors. We know all are the processors with a CPU. We are familiar that with word. First of all, we understanding the basics. Understanding the basics of our processor like CPU. If we have a processor like a processor, it referred to the as a central processing unit. Is the electronic circuitry within a computer that execute instructions stored in a computer programs. Think of it as the brain of our computer, performing all calculation and controlling operation are the components. The processors are the main brain of the like our human's brain. It's a simple example to that. And the core components of the processor control units like uh, the CU, that is a traffic cop of the processor. It fetches instruction from memory and it decode them to understand what needs to be done and then sends a signals to be appropriate components to execute the instruction. That instruction fetch retrieves the next instruction from the memory. The instruction decode from the interprets that fetch instruction to determine the operation to be performed, and the execution control, it sends control signals to ALU. We can send the ALU at that. It's a register and the other components like execute the instruction and the transfer. It moves data between the CPU memory and input or output devices and the ALU arithmetic logic unit. It's a calculator of the processor. It performs arithmetic operator by addition, subtraction, multiplication, division, and logical operations also, and or not. These operations are fundamental to all computer. You know that the calculation from simple numerical communication to complex data processing. And the registers are highly speed storage for location with the CPU. They are stored data temporarily for quick access during processing. The general purpose of register are it used for various purposes such as storing data and intermediate result and the address also. And the special purpose of register is for specific functions such as the instruction register to hold the current instruction, the program counter PC like that, to keep track of the next. It will be instruction address and the status register to store information about from processor current its current state. And the cache also is a small fast memory. It's a small but fast memory like that, that stores frequently accessed data. It's located closer to our CPU than it's the than main memory, which significantly reduces access time. There are some levels of cache. L1, it's a cache of the smallest and fastest cache located directly on the processor chip, and the L2 are the largest and slower than L1 cache, often shared by multiple cores. And there are also L3, the largest and slowest cache shared by all cores on the processor. And we discussed about type of processors, CPU, central processing unit. The primarily process handling most general purpose task. It will examples are Intel Core, AMD Ryzen, graphics processing, uh, specialized for handling graphics and video processing. You know that they're excellent for parallel processing tasks. The examples are Nadia, GeForce, AMD, and the Radeon. There are we know about the micro processor, a single chip processor integrating essential computer for components. It used to embed system, smartphone, and the other devices like microcontroller. It's a small specialized micro processor for embed systems. It controls specific devices for system, digital signal processor like DSP. We are sending DSP. Optimizer for processing signals like audio and processors. The digital workers are understanding the basics. A processor often referred to as the central processing unit is the electronic currently with the computer, the computer instruction, the programs, think the brain of the computer like that with all, and the LU like we can such as storing data intermediately result. It address special purpose for usage specific function. We are know about the smallest we said about the cache and multiple like Ryzen like that short G4s are the graphics like that, and the micro yeah architecture von Neumann. It's a traditional architecture with a single shared memory for both instruction, and the both most modern processors are uh, based on its architecture, hardware architecture. The separate memory units for instruction and data can improve performance by allowing simulation access to both processor performance factor. uh, Clock speed is measured the numerical cycles per second for the measured in GHz, and the core count, the number of independent processing units with the processor cache size, the amount of high speed memory available for the storing frequently accessed data in set architecture ISA, the set of instruction a processor can understand and execute by pipeline, a technique used to execute multiple instructions simultaneously, the superscale execution, a technique that allows to multiple instructions by executed in parallel. By the future trends in processor technology like AI, acceleration, it specifies hardware from AI tasks, and the quantum computing. It's a low-working quantum mechanism for massive computation power, energy efficiency, reducing our power consumption like and heat generation, and the numeric computing. It inspired by the human brain. You know, that aiming for more efficient and flexible computing, in-depth analysis to delve deeper. You can explore topic like processor by pipelining, how to processor break down instruction into stages to improve performance, and the beside the cache space like uh, it's a multiple core access and update shared cache data memory management. About the memory management, how to it's a process management, different types of memory like RAM, cache, virtual memory processor like that. It's also like process executive mechanism to protect against vulnerabilities to and attacks by understanding the analysis of processor, the architecture and the operation. You can gain a deeper appreciation for incredible complexity of it, modern use and audio of and video processing, telecommunication and other application also. Processor architecture, we are traditionally architecture with a single shared memory for both instruction and data. Most modern processors are based on this architecture. Harvard architecture, it's a separate memory units for instruction and data. It can improve performance by emulating both processor performance, like we said, the clock speed, the cycle second measured in GHz, and the cache size, instruction set architecture, pipeline like that, and the AI acceleration. It's a specialized hardware for AI tasks. It's a quantum computing like that, and the processor pipeline. How to processor break down instruction into stages to improve performance, and the what we say ah, by understanding its intricacy of process architecture and operation, you can gain deeper appreciation for the incredible power and the complexity of the modern computers. Okay, this type of points I today discussion. Okay, bye.